Hi, I am Gerimae Abucay. I am going to report the additional rule. The addition rule. There are two objectives: are how to determine whether two events are mutually exclusive. Number two, how to use addition rule to find the probability of two events. Mutually exclusive events. Mutually exclusive events. Two events are mutually exclusive if they cannot occur at the same time. A and B have no outcomes in common. Sample space. A and B are mutually exclusive. The second box, A and B are not mutually exclusive. If sa second box, if kanang magdikit siya, dili siya matawag og mutual exclusive. If magbulag sila, matawag sila og mutual exclusive. For example, determine whether the events are mutual exclusive. So explain. Event A, roll a 3 on a die. Event B, roll A4 on a die. So ang answer is mutual exclusive because the first event has one outcome and 3. The second event also has one outcome, A4. These outcomes cannot be occur at the same time. For example, sample number 2. Event A randomly select male students. Event B randomly selected a nursing major. Not mutual exclusive because the student can be a male nursing major. Example number 3. Event A randomly select a blood donor with type O blood. Event B randomly select a female blood donor is mutual exclusive. Or no, not mutual exclusive because the donor can be a female with type O blood. So here the formula of addition rule. Addition rule for probability of A or B. The probability that events A or B will occur is probability of A or B is equal to probability of A plus probability of B minus probability A and B. For mutual exclusive events A and B, that rule can be simplified to probability A or B equals probability of A plus probability of B can be extended to any number of mutual exclusive events. For example, you select a card as a standard deck, find the probability that card is a 4 or an ace. Solution. The events are mutual exclusive because if the card is a 4, it cannot be ace. Cards is have at 52 cards there. Have 4 ace, 4 diamond, 4 heart, 4 diamond, 4 spade. Then probability of 4 or ace is equal to probability 4 plus probability of ace is equal to 4 over 52 plus 4 over 52 is equal to 8 over 52 is equal to 0.1.4. Igamit niya ang formula is katong addition rule to find probabilities. Example number 2. You roll a die, find the probability of rolling a number less than 3 or rolling an odd number. Solution. The events are not mutually exclusive because one is an outcome of both events. So, here are the solutions. So, roll a die sa box. Inside the box, roll a die. Then probability less than 3 or odd is equal to probability less than 3 plus probability of odd minus probability less than 3 and odd is equal to 2 over 6 plus 3 over 6 minus 1 over 6 and is equal to 4 over 6. So copy the denominator and and add 2 plus 3, 4, ay 5. 5 minus 1 is 4. So 4 divided 6 is equal to 0.6667. Example of finding probabilities of mutual exclusive events. The frequency distribution show volumes of sales in dollars and the number of months in which a sales representative reached its sales level. During the past 3 years, using the sales pattern, find the probability that the sales representative would sell between $7,000 and $124,999 next month. Sales, though these are the sales. So sa inside the box, uh, 0 negative 0 minus 24,999 is mabayad ka tang 3 months and so on and so forth. A is equal to monthly sales between $75 and 99,999. So as you can see, the box, the sales volume and months. The 75,000 minus 999 is mabayad ka as a 7 month. Ka 7 month. Then B is monthly sales between 124. A and B are mutually exclusive because monthly sale volume, monthly sales between 75,000 and 99,999. Then ang B event nimo, event B is monthly sales between 100,000 and 124,999. All other monthly sales. So here's the the formula of addition rule. So probability of A or B is equal to probability of A plus probability of B is equal to 7 over 36 plus 9 over 36 is equal to 16 over 36. So, run off is 0. You run off the 16 over 36 is equal to 0.4444. Example. Another example of addition rule. A blood blank catalogs the types of blood, including whether it is Rh positive or Rh negative, given by donors during the last 5 days. The number of donors who gave each blood type is shown in the table. Find the probability that donor has type O or type A blood. So first column have a Rh positive and Rh negative and the total. The second column we have type O. The second column type A, the third column type B, and the fourth column type AB, and the fifth column is total. The Rh positive have a type O have positive type O have a 156, and the type A 139, and the type B 37, and type AB is 12, the total of 344. Well, the Rh negative type O have a 28, and type A have a 25, type B have a 8, a type AB 4, and total of 65. The total of type O is 184, while the type A is 164, type B 45, and type AB 16, and total of 409. The events are mutually exclusive because a donor cannot have a type O blood and type A blood. So, probability type O or type A is equal to probability type O plus probability type A is equal to the total of type O is 184, and the over of the Rh positive and negative is 409, plus the overall of type A is 164 over the the type of blood is the total of type of blood is 409 is equal to 184 plus 164 is equal to 348 over copy the 409, copy the denominator is equal to run off is equal to 0.851. Example number 2. Find the probability that donor has type B or is Rh negative. The first column have a blood type, uh, have a positive and negative, and the second type O, and the third type A, and fourth type B, and the fifth is type AB, and the total. Find the probability. So, solution. The events are not mutually exclusive because a donor can have type B blood and be Rh negative. So, so there are the solutions. So, probability type B or probability of negative, a Rh negative rather, is equal to probability type B plus probability Rh negative is equal to probability type B and Rh negative. So is equal to type B have 45 total of type B total of 45 over 400 the total of the blood type plus 65 because the Rh negative, the total of Rh negative is 65 over the total of the blood type is equal to minus rather 8 the type B the type B Rh negative is 8 over 409 is equal to copy the denominator then 45 plus 65 minus 8 is equal to 102 run off is equal to 0 or run off into decimal 0.249. Oh, a summary of probability. Types of probability in words and in a symbol. So classical probability. The number of outcomes in the sample space is known and each outcome is equally likely to occur. Probability of event A is equal to number of outcomes in event A over the number of outcomes in a sample space. Second, empirical probability, the frequency of each outcome in the sample space estimated from experimentation. Probability of E is equal to frequency of event A over total frequency. Range of probabilities rule. The probability of event is between and one exclusive. The complementary events, the complement of event E is the set of the all outcomes in the sample space that are not included in event E and is denoted by E complement. Multiplication rule. The multiplication rule is used to find the probability of two events occurring in sequence. Addition rule. The addition rule is used to find the probability of at least one of two events occurring. For example of combining rules to find probabilities. Use the figure to find the probability that a random selected drop pick is not a running back or a wide receiver. So, as you can see, the box, then define event A and B. So, event A, drop pick a running back, and event B, drop pick is a wide receiver. These events are mutually exclusive so that the probability that drop pick is a running back or wide receiver is probability of A or B is equal to probability of A plus probability of B is equal to uh, 23 over 253 plus 31 over 253 is equal to 54 over 253. Solution. By taking the complement of probability of A or B, you can determine that probability of random selecting, and draft pick who is not a running back or wide receiver is 1 minus probability of A or B is equal to 1 minus 54 over 253 is equal to 199 over 253, round out to decimal, 0.787. That's all. Thank you.